Swayam Prabha. Digital India. Educated India.
Let us continue with shear strength. In the last lecture, I have taken some aspect of shear strength, that is, I have explained that soil can have two shear parameter C cohesion and phi angle of internal friction. There can be different types of soil. One particular soil only can have phi, the angular interval, that is cohesionless soil, that is called cohesionless soil, and that is suppose sand is example is sand. Similarly, some soil can have only cohesion, that is called cohesive soil, and the example is pure clay, but most soil is combination of both C and phi, that means it may be a mix of silt, clay and sand. So, if you test, then you will get both C and phi, that means this type of soil will offer resistance by both cohesion and friction. So, and then the cohesion parameter is we are universally denote by C, and frictional parameter we generally denote by phi, angle of internal friction phi. And then if I know C and phi, and if I explain that there are different normal stresses, that is sigma 1, sigma 3, and then how relate sigma 1 and sigma 3 relate to C and phi, we have shown in the last lecture. Now, we will see how, what are the, and also I have mentioned that by conducting the test, we can determine the C and phi parameter, because I can on an identical soil sample, if I carry out two tests, since C and phi is not changing, only change is we are applying different normal stress, and then we are getting different failure shear strength, and based on that I can set any number of I can conduct any number of tests, and I can set any number of equation, and only by taking two equation necessary two equation only necessary to solve two unknown parameters C and phi. So, I can pick I can take two combination, and then we can find two set two equation and then solve them to find out C and phi. So, that is much I have just mentioned in my previous lecture. Now, I will try to show what are the different tests available for determining the shear strength of the soil. So, those things are these are different tests. Actually, in soil mechanics popularly we can use one is direct shear test, and the name direct shear test actually is very clear. We prepare a soil sample and we give a predefined shear plane. There will be soil will be there and in two halves and in a box, and the middle part of the box actually is not connected. Before preparation of the sample, we connect it and compact it, and when while doing the test, we remove the connection, and then we try to slide one lower half with respect to other half. Then the shearing only can take place only that in the between the box, that where we have put, that is the predefined or predetermined shear plane. So, directly we are trying to force the soil flail on that plane. So, because of that it is called actually direct shear test, and then there is a direct shear test will be suitable for some test, some soil type. All soil cannot all soil can be tested, but popularly or commonly we use for cohesionless soil, that is sand, and obviously we can do for other soil, but it is not so simple. Whereas next one is a triaxial shear test. This triaxial shear test is a unique one and universal one, This one actually triaxial, that is 3 types of test stress we can apply, and in fact, as I have mentioned before that if this is a ground mark and if I take a sample from here and if I take a sample here, the stress condition here and here is totally different. So, if I collect sample here and test and get the shear strength parameter, you will get some value, and if I collect sample from here and test, then I may get a different shear parameter. So, what is the reason? Because the stress level, stress condition is different. So, in the triaxial test is a test where we can simulate this condition, that means, whatever stress condition are there, under that stress condition I can conduct the test. Similarly, at this point whatever stress condition is there, similar stress condition I can simulate in the triaxial set and get the value. So, that is the one exact condition we can simulate through triaxial test by applying different stresses in different direction, and this is 3 direction actually, and 2 direction will be identical since we use a cylindrical sample. So, sigma 2 and 3 will be same and equal, and sigma 1 will be another the measure principal stress. So, triaxial system is a universal test where we can vary different parameter and we can simulate different field condition. So, because of that, this is a very universal test, and any type of soil can be tested by triaxial shear test. And next is unconfined compression test, that is also a this is also a test similar to triaxial, but only thing it is unconfined, that means there is a no all round pressure, only in all direction pressure will be there. So, the special form of triaxial test is the unconfined compression test. When there is a triaxial test, the sample will be given compression from this all direction, it is confined from all direction, and then we are shearing. Whereas, in unconfined compression test only load will be of this direction and there will be nothing confinement, no confinement. So, if I remove the confinement from triaxial test, it become the unconfined compression test. And another test is the vein shear test. This is a test actually sometime very useful for very soft sensitive clay, sensitive soil, mainly because this type of soil when this is a field test. In fact, this type of soil when you make sample and try to do test in the laboratory, during this process lot of changes take place, and because of that we do not get the correct representation of the field. So, because of that, for soft sensitive clay, this is a test field test directly we carry out in the field itself to get the strength parameter of the soil. So, this is applicable only for very soft and sensitive clay soil, not other than that. Sometime we carry out in the laboratory to explain or to demonstrate, but it is actually a field test. Now, as I have mentioned, the first one is the direct shear test. So, direct shear test is a typical box is this one. This is a box, and you can see this is the upper half and this is the lower half, and this is jointed initially fixed, and then in between this sample is prepared, and this box will have standard dimension in the laboratory test 60 millimeter by 60 millimeter, and for generally normal soil, but if the bigger particles are used, particularly your gravel and all, sometime large box size can be used, and 300 millimeter by 300 millimeter box size, sometime big gravel test actually used, direct shear test that is sometime will be used in the laboratory also. And in this setup, generally you can see that after preparing the sample I can give the normal load through this. So, that means I can imagine one plane here along this, I can imagine a plane. So, that means this normal force is perpendicular to this plane. Okay. Now, by some mechanism the screw jack or something through that is also motorized, I can push one half with respect to other. Then if try to this ones try to move this direction and this is fixed, then what will happen? This when it will move, this soil also will move and this is stationary suppose, then between this soil and this soil there is a movement. As long as the applied shear stress is smaller than the shear strength of the soil, there is no failure will occur, and as soon as the horizontal applied force is bigger than the shear strength of this, then it will show the failure, suddenly slipping will be taking place. So, based on that we apply different values of normal load and then we shear the soil, and by that way we can get the different soil data, and then from there actually using whatever equation we have got correlating shear strength, cohesion and phi, we can find out the C and phi. So, this is the way, this is the mechanism, simple mechanism, this is box, two halves and the normal load, and then you are moving, giving relative movement with respect to other one. So, so this one if this is the test procedure, and then suppose I will take a set of data, suppose you have got from a test and a particular test, suppose you have applied, as we have seen the normal shearing resistance from friction is function of normal stress. So, because of that test is carried out for different values of normal stress 100, 200 sorry and 100, 200, 300 and 400, and you can see when you have applied 100 same but we are doing different test, but to find out the value of shear parameter, what you need to do, we need to conduct the test on identical sample. That means, with the shear box has to be filled up with definite amount of soil, so that its void ratio, density and all will remain unchanged. So, suppose that is ensured, and then sample 1 is prepared and then 100 kPa normal stress is applied, and then we have applied shear, and suppose by 98 kPa shear stress it failed. So, this is one set of data suppose you have got. Then I have increased the shear normal load to 200 kPa, and then corresponding shear is 139, and then we have increased the normal to 300 normal stress, and corresponding shear stress is 180, and then we increase the normal stress to 400 and corresponding shear stress is about 222. So, we have got this data, and now we know that our equation is tau equal to C plus sigma tan phi, and this is one 100 shear box test were carried out on a series of soil samples with the following results. So, series of soil samples, and this sample actually it is not mentioned the sand, as I have mentioned that shear test is direct shear test is good for cohesionless soil. So, if cohesion is absent, then directly we can do C plus tau equal to sigma tan phi. So, this is the way we can do, but since it is not specified whether it is cohesionless or not. So, we will see the data and see how it comes. So, based on this data, determine the cohesion and angle of internal friction of the soil with respect to total stress. Okay. So, this is the problem. So, let us see, if I take this data in a tau sigma plot, this is suppose sigma this is sigma and this is tau, and this is suppose first point 100 and 98, this is second point 200 and something corresponding value, this is suppose 300 and corresponding shear stress, 400 shear value and corresponding 400 normal and corresponding shear value. So, here actually you can see all points are perfectly on line, but most of the time while doing test in the laboratory you will not get the point, may be somewhere here, point may be somewhere here, maybe somewhere here, but we know that shear strength envelope is a straight line. So, we can in that case if there is a scatter, then we can draw a best fit straight line, and if it is mentioned that is a cohesionless soil, then we can assume that it will pass through the origin. So, accordingly we can draw. Since this soil also has some cohesion, so we need to draw a best fit line, and we will see where it intersect here in the y axis or tau axis. So, you can see tau axis intersected here and the value read as 55 kPa. That means, the soil has C equal to 55, and if I measure this angle that is coming 23 degrees. That means, based on the test results whatever we have carried out, we are getting the shear parameter of the soil C equal to 55 and phi equal to 23. And as I have mentioned that most of the time if the soil is cohesionless soil is tested in direct shear apparatus, and that means, if that is done, then if you get sigma, if you apply and tau you get, suppose you get some value x, you will get some value of y, suppose x 1 y 1, x 2 y 2, x 3 y 3, like that we can get, and those points suppose like this, then we can have a best fit line like this, and then directly measuring this angle we can find out the value of phi, or directly when it is a cohesionless soil is a tau equal to sigma tan phi or phi equal to tan inverse tau by sigma. So, that means, if I though we carry out while conducting the test we will do a number of tests 3 4, but you can see that directly if I apply a normal stress and if I get a shear stress, directly from there I can get the phi value, but still there may be some error in the test and all, and so because of that, to get the average value we generally conduct the test on several samples and finally plot, and then finally to plot the average straight line passing through origin and measuring the angle, we get the value of phi. Otherwise, direct shear test, by conducting one test also one can find out the phi by using this. And now, triaxial test, and triaxial test actually it is the soil sample test in cylindrical sample with a height twice of its diameter. The soil sample tested is cylindrical, that means cylindrical sample, and there will be definite diameter and length, if it is d and if it is L, and you can see that standard if you test on different sample we will get different results. So, best results or maybe very consistent result we get when you maintain a particular L by D ratio. So, that twice height is twice of its diameter, that is a standard everywhere we use, and that standard dimension in most of the laboratory we conduct, that is actually 38 millimeter diameter, and 76 millimeter long, and it was originally actually 1.5 inch and 3 inches. And so, as you convert it, then it comes this. So, all laboratory most triaxial apparatus, if whatever is there, most of them will capable of testing the sample with diameter 38 millimeter and length 76 millimeter, and some cases we can also have 100 and 200. So, that means, L by D always the 2 has to be maintained and to get the best result. So, this is the sample regarding the sample. Next, and triaxial test apparatus, how it looks like, as I have mentioned that this is the sample actually, this is the sample, okay. And this sample will be first, this is the suppose pedestal stand on the machine, on that first sample will be erected, and then after erecting the sample, this is the chamber, this is the cell, this is the cell, it will be covered and all should be leak proof, and after covering by this shell we can push water inside it and fill it, and we can apply definite amount of pressure. Suppose I want to conduct with a shell pressure of sigma 3, that is whatever we are applying, that is sigma 3 all round pressure, that is sigma 3. I can conduct suppose sigma 3 equal to 100 kPa. So, I will apply and then close this one. So, under 100 kPa pressure, then everything will be closed, and then there through this load will be axial load will be applied and till it fails. So, this is actually very simple one we are I am mentioning now, because I am applying confining pressure and automatically immediately after confining pressure the soil is saturated, then what will happen? So, pore pressure will develop, and if you allow to pore pressure to develop dissipate, then what you have to allow the consolidate the sample, and that means the inside whatever pressure developed, that has to be released. That by how it will be released? When some amount of water will come out. So, there is a definite path. If I keep the path open immediately after applying confining pressure, if I keep this path open, then some amount of water will come out, and then finally the soil will be consolidated. After consolidating the soil, we can again shear, and during shear again we can apply draining, or you can close the drain undrained condition. There are several ways this test can be done. I will discuss that one later part. Right now, what is the very simple way what I am telling you, that is that first sample will be prepared, then they will be covered by a shell, and in that shell will be filled up with water, and we apply definite amount of pressure which is equal to suppose sigma 3. And now, under that I will keep all valve closed, and now we will be applying a normal axial load to this sample till it fails. So, on a particular sigma 3, how much sigma 1 is there at failure, what is the sigma 1, that is the thing we observe, and after observing that, as I have shown before, sigma 1, sigma 3, C and phi, there is a relationship. By using that relationship we can find out C and phi. So, this is the by and large the triaxial apparatus, and you can see this is the sample, the displacement, that means there is a mechanism how much it is displacing over time or applying load, that can be recorded, and this is the whatever load is applied, that will be also measured through load transducer. There will be load water pressure can be applied through gauge, we can measure, and here actually when draining is required we can keep it open, when draining is not required we can close it. So, these are the universal test procedure in triaxial test. And now, determination of additional axial stress, that means, that means when we apply the shell pressure, that shell pressure will be acting from all direction equally, even from the top. Suppose this is the sample, when this is the sample and this is the chamber suppose, and if I give pressure suppose sigma 3 here. So, sigma 3 will be acting all direction. So, all direction sigma 3 is there, and additionally we are giving some axial load. So, that is what is called additional axial stress. So, from the load transducer it is possible at any time during the test to determine the additional axial load that is being applied to the sample. That means, how much you are applying at any time, that we can find out, that is delta sigma, you can say additional axial load. And another thing is, when the sample is loaded applied with axial load, then sample actually what will have, it will compress and it will be shortening, and because of this shortening, and then there is a chance of change in diameter. What if, since the compressive load is applied, diameter change in what direction, it will be, it will bulge or diameter will increase. And so, so that at any time, suppose I have applied some amount of stress I have applied, but if I consider with original cross section, we will get some value of stress, but if I consider at any level of stress, suppose what is the diameter, initially diameter was suppose d1 and later on diameter changed to d2. Now, if I want to find a sigma 1 was some value and now sigma 2 will be load applied divided by this area at with diameter d2. So, that means, I have to find out the cross sectional area during the test at different level of load, what is the cross sectional area that has to be obtained. And for that actually the cross sectional area at any time can be obtained volume of sample divided by original length minus vertical deformation, and then if I simplify, volume actually is nothing but area into length, and and this is original length actually, that means your expression is A L divided by L minus delta L, and if I if I get cancelled, then A by 1 minus del L by L, and del L by that is actually nothing but A by 1 minus del L by L is epsilon. So, that means, cross sectional area at loading condition will be volume of sample divided by original length minus vertical deformation. If I simplify this one, that will be A by 1 minus epsilon. Okay. So, epsilon is the longitudinal strain. And the principal stresses, you can see now I have mentioned that since we are considering cylindrical sample, and then 2, though we have 3 1, 2 and 3 direction, and since it is cylindrical, that 2 and 3 will be identical and they are called intermediate or minor principal stress, and which is nothing but whatever through shell pressure we are applying sigma 3. The major principal stresses consist of 2 parts. Major principal stresses consist of 2 parts, that is actually shell pressure we are, that means, when your sample is there, we have given all round pressure everywhere, that is sigma 3 already there, and then we have applied delta sigma. So, because of that, these 2 component will become the total sigma, additional axial stress. So, then I can show you that how this can be related. So, what is the additional axial stress sigma 1 and sigma 3, how they are related. So, that can be seen in the next one. You can see that at any stage of test. So, this is the sample and I can visualize that sigma 1 is acting, sigma 3 acting and sigma 3 sigma 1 are acting. Okay. So, this is of course, all around saying sigma 3 and sigma 1. This is the visualization I can do for the sample, but we have conducted or prepared the setup in 2 stages. Initially, we have applied sigma 3 all direction, this we can say, plus we have applied this. So, you can see that means, whatever we have applied, that is nothing but sigma 1 minus sigma 3. So, these 2 if I add, then we will get this. So, that means, whatever additional axial stress we are applying, that is nothing but sigma 1 minus sigma 3. So, if I put this is delta sigma, then you can find out that sigma 1 will be sigma 3 plus del sigma. The del sigma whatever we are measuring, and that plus this will be sigma 1 plus sigma 3. So, that is this is the relationship we can. So, that means, just before failure, whatever the stresses are applied, if I simulate, this will be like this, but we have applied that stress in 2 stages. Initial stage is this, final stage is this, but I have to see now that this is final. So, this plus this should be this. So, that means, if this is sigma 3, then this will be how much? It will be sigma minus sigma 3, and that is actually del sigma. And during test actually, well, different application of different normal stress, suppose sigma 3 is 200, 400, 600, and with then under different confining pressure, I can apply sigma 1 minus sigma, that is del sigma, that is additional axial stress whatever we are applying versus strain, then we get different type of stress curve, and from this I can find out what is the delta f delta sigma delta sigma at failure. That means, delta sigma at failure, from there actually sigma 3 is constant. So, sigma 1 at failure also I can find out. So, if I get that, then sigma 1 at failure and sigma 3 already known at failure. So, I will get these 2 points and I know these are all major principal states. So, I can get this circle. Similarly, another set I can sigma 2 I apply value another value, suppose this one, and then correspondingly I get delta sigma f another 2, suppose this is 1, then I will get sigma 1 and second set, and then corresponding value of sigma 3 already known, suppose this one. Then third stage I another value delta sigma 3 f I get, from there I will get sigma 3 another and sigma 1 here and sigma 3 here. This we get the circle, and joining this circle actually, and you know that your failure envelope will be tangential to the failure the stress circle. And so, if I get 2-3 circle sometime because of the error, so by single circle if you draw, where to draw tangent we do not know. So, because of that if you do 2-3 tests and finally draw a common tangent, and sometimes it may not be tangent to all, but by I estimation best tangent will be drawn where maximum circle will be the line will be tangent to the maximum number of circle, and then finally, we get this failure envelope. From this failure envelope what we get? We get this angle as phi and this C this as C. So, this is the way I can determine the soil parameter, and during this testing soil will be failing. So, different ways soil can fail, and I have mentioned that failure plane theta related to phi, that is 45 degree plus phi bar. So, that angle can be. So, when I soil fails, if I can see that failure plane, the angle if I see, I can measure this angle and then equate to this equation. From there I can find out the theta. This is another type of, this is one type of failure, that is when it failed by shear. Otherwise, sometime if the soft soil, then instead of showing a prominent failure, it may continuously bulge, then it can, that is called barreling. So, if it is excessively deformed, then after certain stage we can stop the test, considering that as a failure, because excessive deformation, and sometime combination of these two, barreling and shearing failure also. So, it fails, it shows a definite shear plane, at the same time bulging also occurs. So, that is also another type of failure, that is barreling and shear, and this is barreling and this is pure shear. So, these are the different types of failure during test we observe in the triaxial test. And then total stress parameter, the undrained shear test parameter. The undrained shear test parameter can be obtained actually by a very simple way, that means you apply your confined pressure, that means cell pressure, and immediately test, and that test will give you the undrained test. That means, we are not allowing any draining, that consolidation is not allowed during draining during the shear. So, sample is prevented from draining during shear. So, that is why it is called undrained test. The shear immediately after the application of the normal load, that is shear test, and immediately after the application of confining pressure in triaxial test. A sample can be tested in 15 minutes. The undrained test can be carried out in 15 minutes time or 15-20 minutes time, but if you want to give draining, that means every application of load excess pore pressure will develop, you have to give time for dissipating the pore pressure, and that takes actually time. So, this is the so if you want to test that type of test, it will take long time, that I will discuss later on obviously, but undrained test can be done very quickly. Some of the problems application I will show you in the next few classes. Right now, I just next slide, and unconfined compressive test, as I have mentioned, that unconfined compression apparatus, that is which is a special form of triaxial test, where we no confinement will be there, and that will be capable of carrying undrained test strength of the saturated clay. So, that is also very quickly can be done and quite satisfactory result we get. So, these are the different tests, triaxial test, a different version is there. So, first I will take some problem about undrained test, and then later on I will discuss in detail what are the different ways of triaxial test can be done, and then each type, what type of data or result we will get, what is the implication of those, I will discuss in the next few classes. Okay. Thank you.